So we're going to do a little bit of review. I'll answer some questions if you have any. We're going to introduce MVC. I talked about it a little bit briefly a little bit last class. So it's a way to organize your application so that it makes sense and is easily maintainable. It's an architecture. So we'll go over that at the beginning of the class. And then we're going to have a demo at the end. So this is kind of the structure that each of the classes is going to have. Some review in the beginning, a little bit of lecture, introducing something new, and then the demo. So what are we going to do in the demo? We're going to continue with our calculator project. So it didn't really work well yet. We could enter some numbers, and they would keep being added to the display. We couldn't really add or multiply, so we're going to add operations. And then we're going to use what we learned in the lecture about MVC. We're going to use that, and we're going to separate the view layer from the model layer. That's what we're going to do in the demo. So first, are there any questions from the lecture that we had yesterday? Last week. Any questions there? Great. So also, I put up a reading on iLearn. So I know those of you who are trying to add, you haven't seen that yet. So there's a reading on iLearn. I would suggest, I'm going to turn this up. I would suggest trying to finish the reading by, so I had it for today. Did anyone look at the reading? A couple of people. Did anyone finish the reading? No. So it's actually a lot. So let's maybe extend that till next week. So it's all about how Swift works, really. So it'll help you understand what we're doing in class. I would suggest reading that. So that's on there right now. And then after this class, I haven't posted the lecture from last week. I'll post last week's lecture, and I'm recording this week's lecture. I'll also post that one. My goal is by the weekend. So what I'm trying to do is post lectures by the weekend. So you can expect that. Yeah, so that was that. Is anyone excited about maybe giving a quick recap of what we did last week, something that we learned? What did we do last week? Yes? And what's your name?
Julian.
Julian, all right.
We made a basic app that has a set of input buttons and an output label where we push the buttons and the numbers append to the label.
Yeah. And then does anyone remember any new concepts? So I can think of at least one thing that probably a lot of you haven't seen yet. It had to do with question marks and exclamation points. Optionals, yes. So does anyone remember anything about optionals? I know we just touched on it very briefly. We're going to go over it a little bit more today. What do you guys remember about optionals? Anyone? Yes, you have?
For null safety?
Null safety, what does that mean?
Just to make sure that, for example, if you do pass a null value to that object,
yes.
It won't crash your app.
Okay, that's great. That's exactly it. How does it do this? How do optionals help us that the app doesn't crash? And so, so the questions that I'm asking right now, these are conceptual questions. The quizzes that we'll have throughout the semester, a lot of them are going to be conceptual, and then for the midterms, there's going to be probably something conceptual and maybe something coding. So yeah, just thinking ahead, so these concepts, make sure that you, if you don't understand something, take notes at home, ask them in class. So yeah, how do optionals help us? How does it work? How do optionals help us that we don't crash the app? Yes?
If you declare something an optional, it will start out as nil, and you have to initialize it for it to become an actual object?
Yes, so it can have nil, you put something in it, and then what do you have to do to get the thing out of it again?
An exclamation mark?
Yeah, so there's some
or
methodology
you
for
unwrap
getting,
it,
yeah, so there's some methodology for getting it back out. We'll talk about some other options today. So yeah, great. Any other things that you remember from last week's lecture? So we learned about optionals. So Julian mentioned something about interfacing between the view controller and the view. Anything? Do you guys remember anything there?
Outlets and actions.
Outlets and actions, yeah. So what was an outlet? What did we do with an outlet?
Outlets are used for receiving or displaying
Yes.
data.
Yeah.
And then actions are used for doing something or running some code.
Very good. Yeah. Great. Yeah. So that was last week. So let's start this week. So yeah, MVC. MVC. Is that large enough? Everyone can read it. What do you guys know already about MVC? So what does it help us do? Like what is it? What does it do? So what does it help us do? Does anyone know already?
Organize our code.
Organize our code, yes. So it breaks our code into these three sections. So the M model, and then V for the view, and then C for the control. So let's, this is a little annoying. Oh well. So let's create a little diagram. So we have the controller. Oh. So the controller, and then we have the model here, and the view here. So if everyone was allowed to talk to everyone else, that's where, if you have a really, the larger your application becomes, the more people can talk, the more components can talk to each other, the harder it is to maintain the code. So what this is going to do is it's going to restrict who can talk to whom, and by doing that, it's going to help us with maintaining the code. It's going to help us see immediately what section does what. And last week's lecture, I talked a little bit about how the iPhone works. So we have these layers there. So each layer was responsible for a certain thing. It's kind of similar here. So each thing has a very clear responsibility. If something doesn't fit the responsibility, we know something's wrong, and we can work on that. So it's easier to find bugs. Yeah. So let's talk about who can talk to whom. So I'm going to create like a division here, and then so any ideas for so from what you've seen yesterday or last week, you saw two of these components talk to each other already. So what did you see last week? Who was talking to whom?
Controller and the view.
Controller to the view. And then, so do you remember the direction of how this was working?
Controller.
Say it again.
View to the controller.
View. So the view was telling the controller what to do?
Control.
Like controller is receiving the information from view.
The controller was receiving the information from the view. So there's some communication in this direction. I'm going to leave that one. We'll come back to that in a second. So that one's a little bit special. And then, so we saw the other direction with the outlet. So the controller was putting something into the outlet of the view. So there's definitely communication going this way with outlets. Outlets. Okay. So and then what was your name?
Marcelo.
Marcelo, you were saying the view was talking back to the controller. So so the way that so the idea, like one other nice thing about separating things into a controller view and model, the view can be very generic. So I can, if the view responds to the same commands, has the same API, I can take the view and put another view there, and it should just be interchangeable. So the view doesn't know anything about the view controller, or it shouldn't know anything about the view controller. The view should be able to somehow communicate that something has changed to the controller. So if there's an action happening, that's what we want to convey to the controller. So that's what we did. So we created an action. So this communication is called target action. So we inside the view controller, we created the on button click action. So that's our target. And then the view, something happened on the view, so the view let the controller know that something has changed. So theoretically, the view doesn't know what kind of controller it's talking to. It just has, so it has a generic sense that, oh, I can tell this controller that something has happened. But what kind of controller I'm talking to, we don't want to specify. So that's communicating here. So I'm going to create one of those dashed lines here that you know from driving a car. So the view does not tell the controller what to do. The view can notify the controller through an action that something has changed, but the view cannot talk directly to the controller. But yeah, the inverse is true. The view can go through this dashed line and tell the view what to do. So let's talk about the model. Any thoughts, any ideas? How does communication work between the controller and the model? Julian?
Controller talks to the model?
Controller can tell, yes, very good.
In terms of telling the model to give it specific data?
Yeah, so let's talk through an example. So the view, so you type in something into the view. Let's say, there was a button click. There was a button click that the 5 button was clicked in our calculator. So the view let the controller know through an action that something happened. And now let's say we want to input this 5 into the model. So the controller can now directly tell the model, okay, you be 5 now. So yeah, the controller can directly talk to the view. And then so we actually have the same separation here. So the controller can talk directly to the model. The model should not talk directly to the controller. Let's think about why. So why should the model not talk directly to the controller? Can you think of any downsides that it could have if the model is talking directly to the controller? Any ideas? So how would you make that work? So let's say, so for the model to be able to talk to the controller, maybe the model would have an instance of the controller. So we would have to know the type of the controller. So we would have to know about the controller. Does that make sense? So the controller can know what kind of model it is talking to, but the model we might be using somewhere else. So the nice thing about separating it into model view control, maybe the model is used in a different model view control. So let's say this is one screen. We have a model here, and we might want to use the same model in a different screen. So if we had some concept of the model talking directly to the controller, then so for each of the screens that we add a model to, we would have to also add the view controller to the model. And so we would be adding things to the model that just have to do with communicating back to the view layer. So the model should be agnostic of the view controller. It shouldn't know anything about what view controller is talking to. There's some way to let the controller know that something has changed. So the model can broadcast, oh, I have changed. And then the controller can tune into a channel that says, hey, let me know that that this and this model have changed. So the model can broadcast changes that are not specific to any kind of view controller, any kind of view. The model can just say, hey, I changed. So they can broadcast. Oh, I used that for the target. So the model can broadcast, just like a radio tower. It can say, hey, I changed, something inside me changed, and then the controller can have a little antenna where it can pick up on stuff that the model broadcasts. So that's how communication can happen. So the controller can pick up on something that the model wants everyone to know, but it's not specific to a specific it's not specific to a specific view controller. So let's talk about one other way that. Are there any questions so far? Yes.
Can you use some like a real example, like tell us what's the model?
Could you say that again, sorry?
Or what's the model like in the real real
What's the model? Very good, yeah. So does anyone have an idea what could be a model? So let's take our calculator. So the view is clear. Like we have what we did on where we dragged all the buttons onto it. That was the actual view. Then we had the view controller, and we didn't really have a model for the calculator yet. So we'll do that in the demo. We're going to add a model to it. So what could be the calculator's model? So what belongs in a model? So model can hold data, and the model can hold things that you can do with the data. So for the calculator, it can hold maybe an operand, so it's something that maybe one operand, maybe two operands. So let's say we want to add one operand to the other. That would be a function on the data that the model holds, so that functionality would be on the model. What are other examples for a model? So let's say you have a survey, like an app that does a survey. So one model might be, so this is where the object-oriented part of this class comes in. So there might be a question type that you create. So what is part of a question? Let's talk about all the things that, if you're writing a survey, what are things that the question model might have? Does anyone have an idea? What would we have to know about the question? Yes.
Like answer choices? Or?
Answer choices, yeah. Let's say there's a wrong answer. So what could be some function on the model that would be associated with that data? Does the question make sense? So the question has some answers. That's part of the model. So it might have some functionality to check whether or not the question is right, is answered correctly. So those are things that are part of the model. So checking, doing computations on things, holding data, those are things that the model is responsible for. Yes?
So in essence, is the model the object that's being stored or used?
So yes, very good point. So often you're getting data for the model from a web server. You're probably going to cache it. You're going to save it to disk. We're talking about iPhones. So yeah, that's going to be, the model is what's stored, exactly. That's a very good way to think of it. Yeah, so we don't need to store the view ever, or the view controller. We can just generate that. The model holds data. The model holds state. Very good. Yeah. Any other questions related to models? No? Good. So there's one other way that the view can let the controller know that something changed that we're going to see a little bit later. It's called delegation. Oh. So the model, let's say there's the view. Let's say we have a screen that has a scroll view. So you have something on the screen, you scroll through it. So things that the view might want to communicate to the view controller is, oh, I just scrolled, or I am about to scroll, or I did scroll. So those are things that the view controller might be interested in knowing that something happened. But we don't want to do any logic inside the view. So let's say someone wants to scroll the view, and we want to change the color of the view. Silly example, but let's say someone scrolls down, we want to change it red. Someone scrolls up, we want to change it green. We don't want to have that logic inside the view, like, oh, if you're scrolling down, make the view red. So we want to keep the view very dumb. The view shouldn't have any logic in it. It should be very, very dumb. This is what the view controller is for. The view controller tells the view what to do. So the view can tell the view controller, oh, I scroll down, and then the view controller can do something accordingly. So so delegation, we're going to see it later. The view is going to be able to, the view has a delegate, so it's going to be a property on the view. So the view is going to have, let's say, calculator view delegate. Or we had the scroll view, so there's actually something called the scroll view delegate. So the view is going to have a property that's a delegate, and then it's going to be of type scroll view delegate. So that's the type of it. And anything that adheres to the protocol scroll view delegate can then interact with the view, or the view can let that entity know that something has happened. So I just mentioned a protocol. So there's classes, there's structs, and then there's protocols. Do you guys, who knows what a protocol is? Okay, so Julian, you've answered. I don't know your name. What was your name?
Scott.
Scott. Okay, so Scott, what's a protocol?
Well, in other languages, it's sort of known as an interface.
Interface, yeah.
Yeah. So it's just like a list of things that whatever adheres to the protocol should know how to do.
Yes. Did everyone hear that? So yeah, a protocol is a list of things that if I'm adhering to the protocol, it's like a contract. I promise that I can do these things. So for, let's say for our calculator model, so models can adhere to protocols. It's probably the calculator model is probably going to have a method for perform operation. So that might be the calculator model promises that it has the capability to perform operation. So now we don't care what exact instance of class we're talking about or talking to. We just care that whoever we're talking to adheres to the contract, perform operation. So a protocol is a contract between two entities that lets us talk to generic things. So we don't want to talk directly to an instance of a certain class, but if we keep it more general, we can reuse it. It's more reusable. It's more maintainable. So yeah. So how does delegation work with the view and the view controller? So the view is going to have a property, a delegate. Inside the view controller, we're going to assign. The view controller is going to assign itself to the view's delegate. So inside the view, we now have a way to tell. Inside the view, we're going to have a way to tell the delegate to do something. So, or that something happened. Not to do something, that something happened. So for the scroll view, it would be inside the view delegate. I did just scroll. So now the view controller knows. Oh, the view just scrolled. Let's change the color. So so the delegation makes it so we don't put logic inside the view. We just let someone else know. Oh, something happened. We want to do something about it. So that's delegation. So words that or method names that are probably going to be part of a delegation protocol are will. Oh, I should close this. What am I talking? Will. Will. So I will do something. I will scroll. Should. Should and did. So I just scrolled. Whoever cares, whoever is my delegate, please do something. I just scrolled. So yeah, this is another way. We saw the target action. So an action happens on the view. We want to let someone know that something happened. Delegation, the view has a delegate. It lets the delegate know, oh, I just scrolled. Do something with it. I don't know what to do with it. I'm dumb. Please do something with it. Cool. Yeah, so delegation and target action, they're blind, structured, that's blind, structured communication. So the view doesn't know who they're talking to, but it's structured. It's either adhering to a delegation protocol or there's the action was defined inside the view controller. So I'm gonna, so this structured, blind structured communication. Oh. Okay, so let's see what else. So let's go back to the model and the controller. So again, who talks to who directly? We have the arrow showing it. So the view controller can tell the view that something changed. So the view controller can talk to the model directly. So this means the view controller is going to have an instance of the model. So for our calculator, let's say the model is the calculator brain. The calculator view controller is going to have a calculator brain instance. So it can tell, the view controller is able to tell the calculator brain, perform this operation. So the controller can talk directly to the model. And then we were saying that the model can broadcast that it has changed. We're not going to use that for now, but there's another way that the controller and the model can interact. So, and it uses a protocol. So the model might be a data source for a controller. So, example, we have a table view, and there's a bunch of cells, so it's pretty much a list of things. So a Twitter feed, so there's a tweet, next tweet, next tweet, next tweet. So our model in this example would be, we would have a Twitter model. So it would have, or it would a tweet model. So it would have all the tweets, and the controller needs some way of asking for what to display. So it probably doesn't want to display all of the tweets, like all of the tweets that have ever been tweeted. That would be a lot of tweets to display. It probably wouldn't fit on your phone. So there has to be some structured way for the controller to ask something of the model. So this is a data source. Data source. And again, so there would be the controller would have, there would be a protocol so a contract between the controller and the model that says certain things. There's a contract between the controller and the model. So a couple of things that are maybe in this contract are count. So how many entries are in the model? So that's one of the contracts potentially. And then so let's say the Twitter table view wants to display the first 6 tweets So maybe at. So what's at position 6? What's at position 5? So that's maybe a contract that these two have between each other. And then, or give me something at position, at this other position. So, a nice thing about using a data source protocol between the two. So maybe we have tweets or users, and we want to reuse the same list to display the tweets or the users. So we could just swap out the data source, but since it's adhering to the same contract, the same principles still hold true. So give me the first user, give me the second user, or give me position, give me item 1, give me item 2. So maybe the same controller can display, the same controller and view can display multiple models. So that's one nice thing about the data source protocol. So yeah, are there any questions so far? So yeah, before I make it a little bit more complicated, who would like to paraphrase what kinds of communications are allowed between the controller and the view? Who has a nice summary? So maybe who would like to talk about delegation between the controller and the view? Anyone? Yeah.
I can try.
Great. So the reason I'm asking is, so it gives me feedback if I'm rambling on and no one has any idea what I'm saying, and then it also gives you another chance to hear it again. So
it's like what you do, like if you want to scroll against, like
yes,
basically what you're trying to do on the screen.
Yes. And then so what direction does the communication? Who can talk to whom, or like
the view?
Yeah. So the
it's
view.
Not
Yes, very good. So who would like to paraphrase what the target action was?
Say that again?
So we had 2 ways of blind structured communication between the view and the view controller. So what was your name?
Cheyenne.
Cheyenne. So Cheyenne talked about delegation. So the view would have an instance of a delegate, and it could tell the delegate, I just did something, so I just scrolled. So Cheyenne talked about that. Another part of the blind unstructured communication was the target action, and we saw that in the calculator briefly with the button. So I guess I summarized that. Cool. So anyone want to tackle how communication might work between the controller and the model? Julian?
So are the target
Yes.
actions the protocols?
So it's not a protocol. So if you remember, what we did with the calculator, so we created this action inside the view controller, and then what Xcode did in the background for us is it just associated. Okay, so this view can react to this action. What you actually can do is, so you could swap out the view as long as it has a number button pressed action. It can talk to the same view controller. So yes, there's a contract there too. There's a protocol that's kind of hidden, but we don't have to deal with it ourselves. Yeah, very good question. Yeah, anyone want to tackle this communication between controller and the model? So let's talk about the data source. Yes.
Can I understand in this way?
I'm sorry, say it again.
Can I understand in this way? So the controller, we use the controller to manipulate the model.
Yes.
So the model here is kind of like here, the calculator is kind of model. Can we see that? All the data inside the calculator is a model.
Yes, so the data is part of the model, and then also actions on the data are part of the model. So the controller only controls the view. So it tells the view what to do, and it gets what to display from the model. That's a very good question. So yeah, So the model would be, and we haven't seen it in the calculator yet, we'll see it a little bit later. So all the operations that we're doing as part of the model, all of the data, so holding two values that we're doing something with, that's part of the model. Yes, another question, what's your name?
So, Marcus.
Marcus, right?
So all of this is like, if I'm understanding, it's just basically data abstraction on like steroids.
Yes.
Right? Like, so
Yeah.
our data is like way off to the left and
Yes.
has to go through the model, and then the model has to tell the controller, and then the controller tells the view panel.
Yes.
So it's like all daisy chained together.
It's daisy chained together, yeah. And
Okay.
it's and very structured, so yes. And you were saying something else?
Oh, no.
Okay, yes?
Yeah, so what kind of methods would we expect to see in the controller?
So what kind of methods would we see inside the controller?
Like basic, generic things.
Okay, so yeah, so what would we see inside the controller? So yeah, so we talked about the scroll view, that if you're scrolling down, it changes the color. So in that simple example, a method in the controller would be change color of view to red. So that would be a method that we might see in the controller.
Like set and get for the model.
Yes, so it would set and get things to the model. Yes, so that's another thing. Yeah, so updating the model with something that has changed after we interacted with the view. Yes.
So the model's more for managing like data, like integers, blah, blah, blah.
Yes. Yeah.
And the controller actually handles more of what's on screen.
Yes. Very good. Yeah.
Well, then that makes everything easier.
Any other questions here? So one thing we didn't talk about yet. So I drew this line here, and we haven't talked about this communication yet. So this actually, from driving, if you remember the double solid lines. So you can think of this as a double solid line. So this is a big no-no. So the model should never talk directly to the view. You had a question, Julian?
Oh, no.
No. Okay. Anyone? I heard something, but yeah. So yeah, the model should not talk to the view. What would be some implications if the model talked directly to the view or the view talked directly to the model? What can you think? What could be bad? So I forgot your name.
Marcus.
Marcus. All right, Marcus.
Well, that's a security issue, right?
So
Directly change data without having to go through any permissions or anything like that.
yeah, maybe. Yeah, could be. Yeah.
Can we get like conflicting like instructions from the model and the controller?
Yes, it could be conflicting. Yes. So another thing. So if other ideas, those are all good. So let's say the model talks to the view. So now, for the model to be able to talk to the view, we would have to have an instance of the view. So now we're screwed with reusing this model for something else. So we have the view hard-coded into the model. So another thing that I haven't talked about or I haven't brought up yet. So who has heard of unit testing? Who has heard of unit testing? So what is unit testing? Any ideas?
Testing your application every way through the, like,
Yes.
in a unit based.
Yeah, so yes, so small chunks to testing small chunks. Testing things that have to do with the view are really hard. How do you test that something's scrolled? Or how do you test what's exactly in this position of the screen? So separating the model from the view makes it that we can test our entire business logic and cover it with tests. So why would it be nice to have something covered by tests? Any ideas? Why would we want to cover our logic with tests?
Easier to debug.
Easier to debug? Okay, so what would be easier to debug?
Possible code changes?
Code changes, okay. So who has left a programming assignment kind of to the end, and then like the deadline is looming, and then you have this idea, oh, I should be doing it completely differently, and you start changing things. Who has done that? I've definitely done it. And then so something doesn't quite work, or like you think you did it all, and it doesn't work anymore. So I'm seeing some nods, yeah. So it has happened to me. So, but maybe the idea that you had is right. You should be doing it completely different. But yeah, if you have tests for all of the individual things that you want your model to do, you can change the entire way how it's written. You can change it all. And you can be confident that it still behaves the way that you want. So if you have everything covered by a test, you can go crazy with refactoring. You can change things how it's done, and you can be very confident that your application still works. So yeah, you can do some view testing, UI testing. It's very hard. I haven't done a lot of it. It's something that I need to learn more about, but I'm very good at unit testing. So I make sure that everything, all the business logic that I have is unit tested. So yeah, that's one benefit. Yeah. So also, yeah. So what are other benefits? There's probably some other ones that I can't think of right now. But yeah, so you don't want to have communication between the view directly to the model. So that's a big no-no. So I'm not going to draw an arrow to even suggest, even like an arrow that's crossed through. I don't even want to suggest that you can talk between the two of them. So are there any questions about like one MVC? Then we're going to go to multiple MVCs. So so let's say you have a calendar. So a calendar has maybe a month view, and then it has, or a year view, and then it has a month view, and then it has a day view. So there you might have, you do something on your screen that has the year view, and you want to see a month. So then so the month view might be a view controller inside, or an MVC inside an MVC. So you might have the year MVC talk to the month MVC. And if you're combining view controllers, the second view controller is, you can treat it as a view. So that's one way how you can combine these. It's a way to create little sections in your app that are completely independent. Maybe I want to display just the month on a screen. Maybe I want to have the month be displayed by the year on the screen, kind of nested. So if you separate everything into neat little MVC chunks, you can reuse. You can maybe reuse certain sections. You can make sure that if you're talking like up the direction, it's not getting really complicated, and you're not creating spaghetti code. So yeah, you can have MVCs inside of MVCs, and then if you do that, the child the smaller MVC, you could think of it the thing here. So we could replace this view with another. So this view might be another controller, model, and view. So potentially, but I don't want to have this be too confusing for now. Good. Any edging?
So in the MVC, within MVC
Mhm.
model, what would that view be talking to?
So let's say we have, yeah, good question. So for now, let's put another MVC here. MVC. So let's say you have the month. So let's say we have. Let's draw a little example for what this might be. So it's probably pretty terrible UI design what I'm doing now, but it's an example. So let's say we have a calendar, and then you have each square is a month. So the entire year calendar for the entire year is our larger MVC, and then so maybe here we have, so this is the year, and then so here we have the month. So let's say, so yeah, so what kind of communication is allowed. So delegation, will, should, did. So anything that's blind and unstructured, or target action. So my guess here, so what could this be? So let's pick, should we pick target action or should we put delegation? Pick delegation. Let's say, yeah, so let's pick delegation. So let's say okay. So let's say for the year calendar, you also have. So part of this MVC is you have selected month. And then, so let's say this one is February. Okay, so let's say selected is not good. Let's do, let's do appointments. Appointments. No, it's gonna look better. Okay, so let's say in the month February, in this view, you can create an appointment. So you click a button and you make an appointment. So in this year view controller, we want to display that there's an appointment. So you would want to be able to communicate to the outer view controller that an appointment has been made. So did make an appointment. So the month MVC in this case would tell the year MVC did make appointment, and then as part of that, as part of telling the year what it is, it would so did make appointment for the 1st of February. So then we're letting the year calendar know that an appointment was made without displaying, so we don't have to know about how, like what happens to it. So we might have another view here that's just the February, come on. So maybe we would just want to display this on the screen. So did make appointment doesn't get displayed here, but maybe there's just a pop-up that comes up. Appointment made for 1st of February. So we don't want to, we want to be able to keep it very generic, what should happen once an appointment has been made. So by using an MVC that controls this, just the month, inside this MVC that controls the year, things that happen inside the month MVC can be dealt with by the year MVC. So the month doesn't have to know about what the year can do, like what people higher up or MVCs higher up know or need to know or do or can do. It can use the delegation to say, an appointment has been made, you deal with it. I'm passing it off to you. That's it. Does this kind of make sense?
Yeah.
Yeah. Who thinks this makes sense? Okay, so still a couple of people who this doesn't make sense to. So yeah, maybe if anyone has specific questions, I can keep trying to drill at this, but it might also be beneficial for us to just see it in action with the demo. Yeah, are there any questions so far? I want to make sure that we don't move on with questions.
So
yes.
In this example, so what is the controller to be controlled is the user, right?
So this is our MVC for the month. So we have a controller, we have a model, and we have a view. So this is an MVC in itself. So we have it in here. Controller, model, and the view. And then, so this entire thing is the view of another MVC. So that's, so we have this. So this is there's some controller. So the year controller. And then so this one is the year controller's. This one is the year controller's view. This thing, and then we have some year model. So does that make sense?
Yes.
Yeah. So we have an MVC inside an MVC, and it's treated. So we're treating this MVC as a view. So the did make appointment is going to be passed to the controller, to the year controller through delegation, and then it can update the model. It can display. So maybe how we're updating the model would be we're putting all the appointments in there. So that would be maybe something that the year calendar model would know about. Or maybe, so we made an appointment, so now the year controller can list all the appointments down here. And it's all done without the month view controller that we can, MVC that we can use separately somewhere else, being able to, so the month MVC doesn't have to know about all this part. So it's yeah, kind of hidden away. So blind structured communication. Yes?
Is there any limit on how many MVCs can I have, or it's just the memory?
Yeah, so maybe if you, a large application might have 20, 30, so 50, depends on, so like a complicated, or an application that can do a lot of things is going to have lots of MVCs.
And is it always like when I open a new one and a new one, when I close this one, it goes back to the previous one, or I can jump to the first one?
Yeah, so we talked about, if I'm understanding your question correctly, so we talked about the views being able to be interchanged too. So so maybe we have a different way of displaying this. So so we can replace the view and it displays it instead of these squares, maybe in a list. So they don't have to be closed, they can be exchanged. Yeah, so if you're changing the way it's displayed, maybe this one goes away. So that if you just have a list, maybe there's no place to make an appointment. So the smaller MVC goes away. So it's all up to you. So the controller for that view decides what should happen. So
let's say I open year and then I open month.
Yes.
I close year, can I keep using month when it is not?
so if you close, so you're saying like you're opening another year?
No.
No.
I had year and then I open February.
Yes.
And I close year, so I just keep February. Can
Yeah. So yeah, it depends on how you structure your app. So maybe, so let's say you click on this, maybe if I'm understanding you right, let's say you click on this, the screen gets filled with this. Is that what you're asking?
Yeah.
Okay, so then we would probably want to keep this view in the background because you can probably quit the month view and you want to be able to see this again. So it probably stays in memory in that case, so if you're displaying something on top. There's different ways of, so the iPhone has like the concept of a modal. So that would be a modal. You click on something, it takes up the entire screen. That would be a modal. So there's also the tab view controller. So if you have an iPhone, you've seen this before. So you have little tabs here, and so you click on one, the screen changes and puts this view controller there. Or it puts this view here. You click on the next one, that goes away. That one goes there. You click on the next one, this one goes away. Next one comes. So it kind of depends on what you're using. So there's the idea of modals. There's the idea of a tap bar, and then there's also the navigation controller. Where so if you click on this, this slides to the side, and it shows you the next one. Yeah, so it kind of depends. And then so this is for the iPhone. Like computers have, where you have more screen real estate, it might look completely different there. So it kind of depends. Good question. Any other questions? Yes?
So here, so for example, you mean like here, this mouse MVC is inside the ear MVC, right?
Yes. Yeah. It's the view of it. Yeah.
Yeah. So can I see like the ear controller also control the mouse controller?
Then you'd be so this controller would be talking to this controller.
Yeah.
Yeah. So that's actually how the communication would work. So the year controller would tell the month controller what to do. So the year controller probably wouldn't talk directly to the view. So probably talk to the controller, and then the controller does some stuff there. Controllers or MVCs might share a view. So you might have maybe, sorry, not share a view. They might share a model. So maybe there's like just one calendar model, and the calendar model is inside here, and the calendar model is inside here. So that's possible. MVCs can share models, yeah. So this view controller, this view controller wouldn't be talking directly to this view. So it would go through that second MVC. Yes.
When you say share models, do you
Yes.
mean share like a version of the model or the exact same data?
Could be both. Yeah. So let's say.
Any modifications made by either controller.
Yes.
Affect both.
Yeah, so let's say your model is implemented with a database. So your phone probably just has one database or something. So let's say you have your iPod. You have all of your music there. So that, let's say your music library is the model. You don't want to create a copy of that just to show it in my app. So, so you can share the exact same. You might make a copy. It kind of depends, yeah. So if you make a copy, if you make a change, it might not, depending on how storing works, it might not be propagated to the other one. Yeah, good question. Yes?
So in this example,
Yeah.
So for example, like when we open the calendar and we have the year controller, right?
Yeah.
And we use that controller to open the mouse, and then we have the mouse controller, and then we select the day, so we have a day controller.
Yes,
so
yeah.
If we go
Yes.
step by step.
Yes.
So is that any effect of the speed or something? Because you see like there's a link like a controller control another controller and control another controller.
Yeah.
So if it becomes too long, is there any effect of the efficiency?
So the question is, if you're nesting a bunch of view controllers and you have to keep them all in memory, does it affect the speed of the application? You have a good point there that the UI is probably the bottleneck for, so if there's an animation, so that takes up a bunch of processing power. So the UI is often the bottleneck, but it's mostly for like processing. So you have to like do something with it. So these, also what the iPhone does for you is it does a lot of memory management. So as we're looking at the actual, so there's the UI view controller. If you look at all of the stuff that the UI view controller can do, one of them is, there's a memory emergency. We need to free up some space. So one of the things that your view controller can do is it can prepare itself to go to sleep. So it can do some last minute adjusting of the model in that case, and then it can say, okay, I'm out. If you want to see me again, you have to create me again. So there's some, so that, especially in the iPhone, since resources are scarce, there are methodologies for dealing with this. So maybe some of it goes out of memory, and when you open it again, it comes back. So
should we, like when we design an application, should we like avoid this kind of design?
So my thought is, so don't optimize too early. See how it goes. Test it on a real device. So the iPhones are pretty powerful, so it's probably going to be fine. For example, let's say you have the navigation view controller. So everything that you click on a button, pops a new new view onto the navigation stack. You click another one. You can do this indefinitely, like thousands of times, because the memory is managed for you. My tentative answer is don't worry about it. Yeah. Yep.
If you're gonna do something like an API call to get like a bunch of data at once, would that be done in the controller and then update the model?
So the controller is only responsible for updating the view.
Okay, got it.
So we want to. There's this mocking alternative definition for MVC. So a lot of applications that use MVC, you tend to stick stuff into the view controller, and then so an alternative meaning for this acronym is massive view controller. So sometimes, so if you look at so someone who is not very good with separating the model logic into its own thing, they might have a view controller that's 500 lines of code or 1,000 lines of code. So it becomes, so the view controller tends to collect a bunch of stuff that doesn't belong there because it's convenient to put it there. So network calls, so that it's maybe your data layer is a database. So it might live here, it's probably going to live here. So we're going to look at something else. Hopefully we have time for an addition, or like something that's on top of MVC, which is MVVM, model view view model. So maybe the database call is somewhere else there, but so it's kind of part of the model.
Got it.
Yeah. So we talked about the model having to broadcast something to the controller that something has updated. So that's a really good example. Let's say the model makes a database, it makes a network request. So now the model is going to have to let the view controller know somehow that something has changed, and that happens through this data source protocol. Good question. Yeah.
For calendar, so does the year controller talks to the view of the month or the control of the month?
Does the year controller talk to the
view of the month or the control of the month?
The controller of the month. So the entire MVC for the month can be treated as the view. So it talks to this as if it was, this whole thing was a view.
Okay.
Yeah. So, and yes, your question was, does it talk to the controller? The controller would be what it would be talking to, yes. Good. Any other questions? Then let's see what time it is.